There, and welcome back. This is Angie with Angie's Beyond the Lecture, and we're looking at this is the second to the last installment. It's about an 8 or 9 installment series on Intro to Chemistry or Chemistry Final Exam Review, and this is tailored for high school chemistry, Intro to College Chemistry, General Chemistry 1. Largely, the beginning few sections of the semester are going to be the same, no matter what level of chemistry you're at. Yes, it does diverge later in the semester. But for now, we're sticking with some very common definitions that chemistry students will see. And to start off with, we're using density, mass, and volume. So we know density is actually a ratio of mass per unit volume, and it tells us how tightly packed a particular volume is of substance. And we do, let me emphasize, it's a physical property in chemistry, right? And so it helps us identify what a particular substance is. All of our substances we work with have characteristic densities, okay? And we have a density formula, again, I'll write it in a more fractional way versus via text. So density, large D, we sometimes see it as this. I think that's rho, Greek or Latin letter rho. And we know, again, it's ratio of mass per unit volume. Now, our common densities that we use in chemistry are going to be grams per milliliter, grams per centimeters cubed. We also see grams per liter. And liquids, solids, they're typically going to use these two right here. And gases, because gases are, they take up a lot more space. They're much less dense. We typically say grams per unit liter of gas in that situation. Now we can back up here. We have three different variables that we're working with, and so you can imagine 3 different scenarios you might be asked to do some math work on and determine, okay, if I have a particular mass and volume, what's my density? And you can also rearrange that original formula to determine that mass is density times volume, and also volume is mass divided by density. And just to take you back to algebra 1, gosh, I like crossing things out here. Density, we'll just say, back up to the top here, density over 1 equals mass per unit volume. If you cross multiply here, you get mass equals density times volume, okay? And that's that equation right there. And then if you divide by D on both sides, you would derive that volume is mass over density. And that would be your second equation down there. So that's the math behind that. And a few other things we can consider when it comes to density, especially water at room temperature. So we're looking at 25 degrees Celsius, about 77, 78 degrees Fahrenheit. We have a density formula that says, okay, for every gram of water, I have 1 mil of water. And I can also cross this over into centimeters cubed. So we know, and we're using this concept here of 1 milliliter is equal to 1 centimeter cubed. So it's almost like you can cross that over. If I'm given, for instance, 20 grams of water at room temperature, I know I have 20 mils of water, and I also know I have 20 centimeters cubed in volume. So it's a nice equivalency, I'm sorry, with my English there, an equivalency statement. So if I have 1 gram per milliliter, right, so 1-to-1 ratio, that means I have 1 gram per 1 mil of, in this case, we're talking about water at room temperature. And so if I have 20 grams of water, I know it's 20 mils of water to keep that 1-to-1 ratio. And, to sort of drive things home, I know I have 20 centimeters cubed. And I've seen sneaky questions where they'll throw in like, I have 20 grams of water, and maybe they want you to determine the centimeters cubed or something like that, where you just simply need to know this part right here. Water at room temperature is 1 gram per milli. It's also 1 gram per centimeter cubed, and just know that under standard conditions. Room temp, what we're talking about there. All right, I think that's it for this particular section. And again, we'll go over problems on these. This is just kind of like a highlight drive-through version of what you need to know. We'll do some examples here. Temperature conversions, we have two primary units that we deal with. Day to day, Americans use Fahrenheit, though in chemistry, we're largely talking about Celsius and Kelvin. Now, Kelvin is the absolute scale of temperature, okay? So we 0 Kelvin means we have whatever substance we're dealing with. 0 Kelvin means all kinetic energy, all movement has stopped, okay? It's a very, very low temperature. So 0 Kelvin, I guess that would be minus 273 degrees Celsius. If we just look at this conversion here, right? If I have something at 0 degree Kelvin and I want to convert it to Celsius, yeah, that's pretty darn cold. I'm just doing the math here. Minus 273. Yeah, 273. Ooh, pretty darn cold. But again, that's the absolute scale that we use in chemistry. We don't use that in our day-to-day lives. But a lot of times, a common example, and I'm just going to erase this real quick, and like room temperature, we typically say is 25 degrees Celsius. And if I'm using this in maybe a gas law equation, I need to convert that to degrees Kelvin. So I'll say, what is that in Kelvin? So Kelvin is, again, so Kelvin is 25 plus 273. 25 plus 273, I believe that should be 298. I've seen that a lot. Yeah. Kelvin equals 298 Kelvin, right? And of course, Celsius to Fahrenheit, Fahrenheit to Celsius, it's a little more complicated. We do have an equation we need to consider. I wish I could say whether you have to memorize that or not. I'd say it's 50-50. You might have to memorize it. Sometimes the teacher will just give it to you and say convert. So if I'm given perhaps I'm at 60 degrees Fahrenheit and I want to convert to Celsius, degrees Celsius. Okay, we'll use that as an example. Fahrenheit to Celsius, I would simply use this equation down here where degrees Celsius is degrees Fahrenheit minus 32. And then I'm going to apply this 5/9 ratio. So ultimately, degrees Celsius would be our 60 minus 32, and then ultimately times 5/9. And if you know one, you know the other. You could always, if you had to memorize, just pick one to memorize and then know how to rearrange it, because this top equation right here is just moving the 32 over and multiplying both sides by 5/9 to cancel that 9/5. So bottom line is you can use algebra. If you know one, you can convert to the other one quite easily. Back to degrees Celsius, I'm going to do 60 minus 32. That's 28. And then times 5, and then divide by 9. So we're looking at 15.55. And what I just used 60 degrees. I mean, I'm not going to worry too much about sig figs here. And I apologize, Yeah, 16 degrees Celsius. Okay, so 60 degrees Fahrenheit, if you're over in Europe, if they tell you it's about 16 degrees Celsius, you know it's roughly 60 degrees Fahrenheit in America speak. Now, a couple things to keep in mind that the temperature differences in Celsius and Kelvin are equal. So what we mean by that is that 1 degree Celsius is equivalent to 1 degree Kelvin, okay? They're just on different scales, all right? They're on different scales. Kelvin being the absolute scale, and then Celsius is just a relative scale that we use, I guess, more or less for weather, human, for our use, for our purpose, right? But Kelvin is largely used in physics and chemistry and so on. So we just need to keep in mind the temperature differences are the same, but the scales are going to be different. Now, if we're doing like a difference, like if I'm subtracting, like a lot of times we have to take the beginning temperature and the end temperature. So if I have a delta T of, say, 10 degrees Celsius, it's going to be equivalent to 10 degrees Kelvin. Like those increments are the same. So that can come in handy when you're dealing with temperature differences and you don't want to convert in the problem. But this leads us to the last section before we go to review problems. So only to recap here, we talked about our definitions of density and how mass and volume contribute to density, and also temperature conversion. So we talked about the three major scales we see. And of course, Celsius and Kelvin are the most common. And of course, you might be asked to convert Fahrenheit to Celsius or vice versa on a test. And that leaves us with the last section. That's intro to atoms and isotopes. So I'll see you in the next video. Thanks for watching.